don't think that's going to happen in the near future. In any event, number 40. Number 40 is g of x equals to 3x squared plus 2 all over x, okay? All over x. And that's kind of a nice, easy one. We're going to go ahead and, first of all, say, let's set the denominator equal to 0. If the denominator is equal to 0, then guess what? X is 0, right? Okay, so we've finished that very quickly. Our vertical asymptote is x equal to 0. That's our vertical asymptote. Let's look for the horizontal asymptote. Horizontal asymptote is the degree of the numerator less than the degree of the denominator. The degree of the numerator is 2. The degree of the denominator is 1. So that the degree of the numerator 2 is not less than the degree of the denominator 1. Forget that one. Are they the same? If they were the same, this would be x, and that would be x, or this would be x squared, and that would be x squared. They're not the same. That doesn't apply. The next one here is the degree of the numerator 1 more. In fact, it is, isn't it? 2 is 1 more than 1. So what we're going to have to do here is we have the only way we'd get a horizontal asymptote is if the degree is less at 0 or if they're the same. If it's more by 1, then we're going to slant asymptote on this, okay? And we'll do that by division. And we're going to go ahead and divide x into 3x squared plus 2. I'm going to drop this maybe over to the side, okay? Vertical asymptote x equals 0. And do put x equals 0, not to 0. It's x equals 0, not 1. When you do the division, we could go ahead and say how many times root 3, well, x go into 3x squared, or what times x will give us 3x squared. And that's, of course, 3x. So how about a 3x there? Let's see what happens there. 3x times x is 3x squared. And then we're going to subtract that. That's how we do our division there. That becomes 0, and there's a 2 left over. We could write it this way. You know, normally in junior high school, you'd probably say remainder 2 like that. If we were doing this with arithmetic, maybe 3 into 17, you'd say 3 goes into 17 5 times, that's 15. There's 2 left over. You'd say R2, junior high school. In high school, you said this. You said, look, we put the 2 on the top and the 3 underneath. 5 2/3. The 2 from here and the 3 from there. We do the same thing here. We could say, instead of just remainder 2, we could say 2 over x, like that. And then, next to each other this way, it looks like we should be multiplying. So even though this means 5 plus 2/3, we normally don't have to put the plus sign in because we know we're talking about the adding anyhow. In this case, it doesn't look like that. So we'll probably put a plus sign in there, okay? And what we do with the plus sign is this. Let's see what happens here. This is our curve y equal to 3x. Excuse me, the asymptote 3x. So that means when x is 0, y is 0. When x is 1, y is 3. This is our line right here. And what's happening is the curve is tending towards that. And the larger x gets out here, the closer this line gets to our slant asymptote. That's the meaning of an asymptote. The farther we go along the x, one way or the other, and the closer it gets to that line. Which means that basically, it's going to get very, very close, very, very close. As x gets bigger and bigger, what's going to happen? Well, what we do is this, say, put a very large number here, really large number there. And then, if we knew what a calculator was, you might just try this. The 2 divided by 1, and just keep tapping about 26 times or so, because your calculator will keep 26 numbers in memory. And then press equal to. And on a very basic calculator, it might be 0, okay? Because the bigger this gets, the smaller the fraction becomes. And if you keep going on and on and on and on, and this symbol that people want to use for infinity, I hesitate to say infinity because it sounds like it's a place somewhere. It really means larger and larger and larger and larger, and never stopping there. The larger this denominator gets, the smaller the fraction gets, and ultimately goes to 0 for all intents and purposes. So we really cross this out and say, look, here's our answer. Our answer is y equal to 3x, okay? Y equals 3x. So I'm going to put that right here, y equal to 3x. That's our slant asymptote. I'll use SA for slant asymptote, or OA for oblique asymptote. slant and oblique mean the same thing, okay? Some books use slant, the other books use oblique, so I'll use them both. And that's y is equal to 3x. So here's our line y equal to 3x. As our curve, as x gets bigger and bigger and bigger, our curve will get closer and closer to that line, 3x. And that's the meaning then of what we call a slant or a horizontal asymptote. Excuse me, slant or a oblique asymptote. There isn't any horizontal. Horizontal will be something like this, and we either have a slant or we have an oblique. We can't have both. Excuse me, slant, not a slant or oblique. We have a slant or oblique, but we can't have that in conjunction with horizontal. If it's horizontal, it's horizontal. If it's slant, it's slant. It's not both. Okay, that should do for number 14. Let's see if we can continue with another one of these, number 40. Now 46 is another one here. And let's see if we can maybe move. Well, we can probably do it here, I think. Well, maybe not. Let's go ahead and erase this, okay? Because you can refer to this if you want by just going back on the video. I can erase that, no problem, I think. Let's go ahead and try 46, okay? 46 is right here, and that's f of x equals to 3x minus 4 over x cubed plus 2x squared minus 9x minus 18. Okay. First of all, let's go ahead and look for the vertical asymptote. The vertical asymptote, we find by setting this equal to 0. And you can see why I chose this one, because in this case, you're going to have to go ahead and factor this. And it's factored by grouping. You should be able to aware of that. We're going to group the first two here, x cubed plus 2x squared. And then minus, and be careful with the minus. Now, we've said this before, that you want to make sure when you group around the minus sign, when you give that back, you'll get your negative 18. And then after that, we still haven't factored this. We're going to check each of these. What's common here is an x squared, and what's common here is a 9. And again, 9 times 2, 9x 18. Looks pretty fair there. And then again, it is still not factored. I think look at the x plus 2. We'll factor that out. What we're left with is x squared minus 9. And then we can factor that x squared minus 9. You should recognize that as a perfect square minus a perfect square. It's going to factor to the numbers without the squares with a plus between, and the numbers without the squares with a minus between. So overall, what's going to happen here is we're going to say, look, first one equal to 0, second and third. We're going to say x is equal to negative 2 and basically plus or minus 3. Those are in fact 3 of the vertical asymptotes we have. 3 vertical asymptotes. The vertical asymptotes for this particular problem are x equal to negative 2 and plus or minus 3. What about the horizontal or the oblique asymptotes? Horizontal asymptote, let's see how it conforms to our definition. The horizontal asymptote is the denominator, degree of that denominator. Is it less than the numerator? Is the degree of the numerator less than the degree of the denominator? Numerator is here. Degree is 1. Numerator there is the denominator exponent 3 degree. The degree of the numerator looks like it's smaller than the degree of the denominator. In that case, then this should hold if the degree of the numerator is less than the degree of the denominator. Y equals 0, or the x-axis is going to be our horizontal asymptote. Okay? So in this case, then, we found both of them. The first one done the same technique by letting the denominator equal to 0. The second one, we check to see is it less than the degree of the numerator, less than denominator, equal to denominator, or greater than. Greater than by 1 we already did, and we did less than. I hope we can get this one in, a nice easy one there when the degrees are the same. Just pick out the coefficient, that's very nice. I hope I've selected that to do today. If not, because of the time, we'll probably have to approach that in another session. I think I have, yes. So you might see one of those in your exercises that you're doing for yourself. If not, that's what the conferencing is for. We can play with that during the conference if you need to, okay? I'll hopefully have a whiteboard behind me somewhere where I can address those considerations. Let's see what we're up to after this. We're going to, after this, in fact, we finished with that page, I guess. We're going to page 378 now, and 378 is, we're going to be asking about less than or greater than situations, and let me get to 378, and I'm going to do number 6 first, and I'll try to make that as nice as I can. This is 378. How are we doing number 6? We'll probably have no need for this. Well, let me leave it just in case. I don't think we're going to use that anymore. But since it's here, might as well leave it for you. Just in case we need it again, I can refer to it. Number 6 looks like this. This is the point 1, 4. Right there. And then at negative 1, 0. And over here at 3, 0. Okay, these are our points we're looking at. 1, 4, negative 1, 0, and 3, 0. And we have our curve going through these points. It's parabola opening downwards. We're going to ask for a few questions here. And the first one is, and what I'll do is I'll put the answers in here while I'm at it too, just to save a little bit of writing, and then talk about them there. And the answer here for this one is x less than negative 1 or x greater than 3. For B, f of x less than or equal to 0. And this is really just the examination of the curve, or going ahead and analyzing the graph a bit here. Part C, f of x is greater than 0. And again, this might be notated differently in the back of the book. So I'm using the standard notation. The back of the book might use the interval notation. Either one is fine. I tend to find this a little bit easier to play with. And all we're doing is analyzing by looking at it here. We're saying, let's take a look and see what's going on. Where is y less than 0? Well, this is y equal to 0, the x-axis. Y is less than 0 all the way down here, isn't it? So where is the x when y is less than 0? If x is smaller than negative 1, less than negative 1, we're going to have be below the x-axis. If x is greater than 3, the graph will be below the x-axis. So that's what's being said here. When x is less than 1, when x is over here, then y is below the axis, or less than 0. When x is greater than 3 already, when x is over here, y is also below. So these are our two answers for A. The function y, if you would, is less than 0 below the x-axis at these areas right here. Where is it below or equal to? Well, then we're going to include the points here, and that's why you see the equal to sign underneath. Not only in those intervals, but also at those various points below the axis. So I'm going to say equal to there on that. Where's it greater than? Well, it's above the axis here, isn't it? It's above here. Anywhere that's between, in fact, the x is between negative 1 and 3, isn't it? Between negative 1 and 3, isn't that y all above the axis between negative 1 and 3? So where is y above the axis? Between negative 1 and 3 on the x. And if you want to talk about the equal to situation, where is it greater than or equal to, then we'd include the points here, and that would be less than or equal to x and less than or equal to 3 there. So those would be the answers. That's by looking at the curve and giving some information. That kind of gets us into the inequality situation. Now we're going to start to play with those as equation or as inequalities in just a minute. Okay. Number 6. After number 6, we're going to jump down to number 24, and 24 looks like this. And we'd like to solve this inequality. I didn't write that down, but if you check in the information, the text, it should say solve this inequality. And that's 24. We'll get to that in just a minute. And I think after that is, looks like
like we're talking about 37 after that.
Let's hope that's enough room to deal with that.
And I think I want to do one more on this page 65 with you also, and then push on to the next page 388.
But let's do these two, we'll put the next one on the board when we get there. And we probably won't need this information anymore, I think, so we'll get rid of this too, all right? Okay, let's see.
We want to solve this. Usually we try to get the letter on the left side.
It's easier to say y is less than 7, rather than saying this same thing. This one says 7 is greater than y. They both mean the same thing, just turn one around and get the same thing. But in this case, we're talking about what y is. In this case, we're more or less talking about what 7 is. So we'd like to have the y, for the inequalities at least, doesn't have to be, but it's kind of nice to have it done if we can. So I'm going to try that. The first thing you know, what we should do is, you should know this before I ask it, is that, right? Probably the most important property in math. Call it again, distributive property, right? Okay, let's do that. This is 5y squared plus 7y is less than 3y plus 12. We'll proceed to try to get the everything, in fact, on the left side, because we want to get this equal to 0. It's quadratic. So you should know we'll probably subtract 3y and subtract 12. Okay? So I'm going to subtract 3y and subtract 12. This is 5y squared. 7y minus 3y is a positive 4y. Minus 12 is less than 0. And then we know what's coming next. And we're going to try to factor this. Try to factor that. There's 5y and y. And 12, I'm thinking, is either 12 and 1 or 3 and 4 or 6 and 2. And I'm probably going to go with 6 and 2, I think. Just take a wild guess on that. And if you couldn't see that, then practice it a bit. There are only a few possibilities. If you try 12 and 1 either place, that's not going to work. Nor will 4 and 3. I think 6 and 2 will. Let's try.